Okay, questions? No one talking. Okay, real quick. Just a few people got stuck in a couple places. One thing about this packet that can be confusing, this is my fault, not yours. This problem is saying look at the velocity graph and then make a comparison to the position graph's concavity. So they want you focusing here, comparing velocity to position's concavity. The trouble is the position graph is concave up, then position is concave down, now position is concave up again. So it's not clear from the packet like where on the graph you should be looking. So that's my fault for not making that clear. It's not your fault. If this had been a test question, there actually are multiple correct answers, and any of them would be acceptable. I believe in the back on number 8, they were having you focus in this region, noticing that the velocity graph is, let's see, I'm not sure. What. Somebody look in the back real quick. How does 8 start out? Decreasing. So they actually said, looking here, where they said velocity is decreasing from time 0.2 to about 3.3. When the velocity graph is decreasing, the position graph must be concave down for that same time frame. This one, I believe the correct answer back is 0.2. Is that correct? Help me, somebody. Yeah. 0.2. So then the worksheet comes back and focuses here. You could have focused here and it's still correct, but the answers in the back go back to 0.2. That's all. Somebody else said they struggled a little bit understanding how to identify concavity. It's not possible to look at a graph and really find exactly where the concavity changed just by looking at it. That's why you need Danica's chart. Like, I don't want to look at position and say, okay, no position is concave up, now position is concave down. Where that change occurs is not easy to see. But if I don't look at position, instead I look at the acceleration, then it becomes much easier. Because when the position is changing concavity, the acceleration is changing positive to negative or vice versa. That I can see really clearly. So that's how I figure out where the inflection point is on the position. Follow-up question? Okay, go to the new pocket. Okay, the first 10 problems are just matching problems. Number 1, I would recommend you write this note on your paper. Number 1, they're giving you a graph of F, and they want you to find which of these graphs would be the appropriate matching F prime graph. Please.
I didn't get a packet.
So, mark that on your paper. And in number 1, they're giving you F, and they're asking you to find F prime. Well, number 2 is, oh, see.
So like find the velocity graph?
You can think of it that way.
Okay.
Just don't do this. Don't memorize that F is position. Doesn't have to be. F could be velocity. But if we say that F is position, then absolutely F prime is velocity. So that's a perfectly correct way to think of it, that, hey, they're giving you the position, they want the velocity.
Okay. And how do we realize that that is a position?
Gotcha. The wording's a little tricky, but here's how they wrote it. Which of the following graphs, A through D? So which of these could represent the slope of the function graph here? So again, remember, when you look at a graph, all you see are points with numbers. So all of these points, all of these y coordinates down here, their slopes of this. For example, right here, the tangent slope is 0. That's x equals 0. That means down here, for there to be a match, at x equals 0, the y-coordinate must be 0. So these three match. This one does not. Here on f prime, I've got x equals 0 and the y-coordinate is 1. That would be telling you that up here, the tangent slope would have to be 1 at x equals 0. Did that help? 2 points for later. Anybody else want to talk about it? I'll let you finish this one, but that was just answering her question. So, okay, make note that problem number 2 is exactly the same question, just different graphs. So giving you a graph of f, you're supposed to identify the correct matching f prime. Number 3, same thing again, just more practice. No, it's very good, Justin. You're looking up here and you're saying, hey, in fact, where I always start is I start with the easiest tangent slope to identify, 0, horizontal. So I'd say, look, right here, tangent slope is 0. Here as well, this is about an x-coordinate of maybe 0.7 negative. So down here, at that same x-coordinate, I have to find a y-coordinate whose value is 0. So I've eliminated those two. The y-coordinate here is wrong. This y-coordinate has a negative number. That would mean the tangent slope right there would have had to have been negative. Is that your question? Good work. Okay. I say all the time that the AP test writers are very clever. They come up with brand new ways to just mess with your brain, okay, to try and get you stuck. This is one example where they actually have been fairly straightforward. It seems like pretty much every year, one of the multiple choice questions is something like this. So this one is a case where once you get the idea of how to look at f, find f prime, it's usually not too bad. So number 4, same thing. Number 5, same thing. 6 is different. No, 6 is the same. Sorry, 7 is different. So please make note that on 7, 8, 9, and 10, they have reversed the question on you. Now they're giving you a graph of f prime, and you are supposed to identify which of the following graphs is f. Question.
So what would you consider just like?
We'll talk about it together in a second. Just want to make sure you have the instructions. So 7, 8, 9, and 10, they give you f prime, you have to find f. After that, the problems become a little more clear as to what they're asking. Those first 10 was a little bit weird. Go to number 6. We'll work on that one together. Okay, as I already mentioned, where I always start is I look at f and I identify which tangent slopes are easily visible. So this one at an x-coordinate of maybe negative 1.7. The tangent slope right there is 0. Here the tangent slope is 0, and here again. That means here the y-coordinate must be 0 at those exact same x-coordinates. So on a graph of f and f prime, the x-coordinates all line up. Okay, they're always the same. What you're comparing is tangent slope to y-coordinate. So this y-coordinate equaling 0 is a perfect match for this tangent slope equaling 0. You need me to say that again? Just wave at me.
So basically the tangent slope equaling 0, let's just say, is like negative 1.7. So like 1 negative 1.7 on that has to be 0.
Yep. So Justin said that nicely. I'll say it again. So up here, you're saying, hey, look, on f, at x equal 1.7 negative, the tangent slope is equal to 0. This is not an AP abbreviation, so don't use it, but for your notes it's fine. But that means down here, at that same x coordinate, the y value has to be 0. Because we're just looking at data, and these y coordinates all represent the slopes of this. Is that better? Do you need me to say it again? Just wait.
So the tangent slope is compared, like, what are the tangent slope that's the y-intercept?
Not y-intercept, y coordinate. Y coordinate. Yep. Like right here, that x coordinate is 0. And at that spot, the tangent slope of this f graph, this tangent slope is horizontal, it's 0. So down here, at x equals 0, you have to find a y coordinate whose value is 0 for that to be a match. So far these are matching just fine. Question? So I want you to answer something. It's kind of a trick question, so if you can see why I say it's a trick question, then I know you're understanding. Raise your hand if you can tell me, can any of these be eliminated based on that comparison of looking at tangent slopes here that are equal to 0, knowing that I have to find on f prime y coordinates that are equal to 0 at the same place. So raise your hand if you can tell me, can any of these be eliminated, why or why not? Hands up. Feel free to talk to each other.
Why? Because they all. Yeah, they're all there. Yeah, that's.
Show me your hands. Who can talk to me? Come on. Hands up. Show me hands. Can any of them be eliminated? Why or why not? Looking for hands. Let's go, Dawson.
No, because they all have the y-axis on negative 1.70 and 1.7.
So up here, I have tangent slopes of 0 at those 3 spots that Dawson mentioned. So here on f prime, I have to have y coordinates of 0 at those same 3 x coordinates. And I do. So the AP test writers, as always, don't make it straightforward. So how many saw it? Point. Dawson got a couple of them. This his name twice. Question? We need to go through it again. Just wait. Well, so now we have to check something else. So now I just use Danica's chart. And you can either look here or you can look here. Either one. There's no way of knowing which one will be better. So some problems one way is better than the other, but there's no way to know ahead of time. So here we go. F is increasing. So right here, this purple section of F is where F is increasing. So that's from x equal -2 to x equal 1.7. That means on that same span, the y coordinates of f prime must be positive. These y coordinates are negative. That's a mismatch. This negative y coordinate is telling you that this tangent slope up here would have to be a negative value. But the tangent slope right here is positive. The slope is going upward. Danica's chart confirms that when f is increasing, f prime has to be positive. So this does not work. Wait, can you need to say it again?
So that means you can eliminate A and B.
Yeah, very good. Same problem, right? All of these y coordinates are also negative, but all of these tangent slopes are positive. So when the tangent slopes on f are positive, the y coordinates on f prime have to be positive. These two work. This section is just fine. So is this section. Question? Please.
Wait, can you explain that one more time?
So again, I'm looking at f, trying to find f prime. these y coordinates match with these tangent slopes. So if I draw tangents along here, every tangent that I draw, you tell me, is the slope of each of these tangents positive or negative? So that means the y coordinates down here in the same space must have positive values. Well, all of these y coordinates are negative, because I'm only looking at this little space right here. And in that little space down here, all the y values are negative, so it's opposite. When f is going up, I should find positive y coordinates. Here I find it. For x from -2 to 1.7, on f prime, I see all positive y coordinates in that same span. Does that make sense? Good job, Cindy. Anybody else just worry about me? So just keep checking. Let's see. Decreasing. So f is decreasing from here all the way to here. That means f prime must have y values that are negative over that entire span. This is the problem. These y coordinates are positive. So the correct answer is C.
So even if the line flattens out on the top graph, it still technically has an increase, so is it still considered increasing? I mean, like it's at 0, but it's like...
It's hard to see, but what's really happening is if you could follow the points perfectly, you would find that every time you stepped to the next point, you would go down a little. Right in the middle, the tangent is mathematically flat, but even if I'm on that middle point, my very next step is actually downward a little. If I were to go back this way, my very next step would be upward a little. Again, that's not really true because it's infinite, but at least my brain can handle it. So, does that make sense? Just don't want anyone to sue me like 20 years from now and say, you told us there were steps. There's no steps. They're infinite. Like, yeah, I know, but it's the only way I can get you to understand it. Questions? Cool. So we're done with that. I'm going to talk through it again. Cool. Go to number 9. Make sure you notice the sign about the test. So, one on both sides of the board. Okay, this one's going the other way around. So this one we're starting with f prime, and we're trying to find out. Okay, I always start at the easiest spot. The easiest spot is where the tangent slope is 0. Well, here, given f prime, I'm going to start at x equal 3. Because when x is 3 and the y value is 0 on f prime, hands up, okay, everyone who raises their hand, what does that information tell you about the graph of f? Okay, everyone who raises their hand, we can talk to each other always. So what does this information, Allie, tell you about the graph of f? So up here, since at x equal 3, the y coordinate is 0, down here at x equal 3, the tangent slope must be 0. So this is not going to work. That is not a tangent slope of 0. This also is not a tangent slope of 0. These two are fine. So who had their hand raised? Show me. Point for that. Who got it right? Point again. Questions? So now I have to pick between these two. So we just go down the list. Let's see. F prime. This F prime is always decreasing. So F prime is always decreasing. So the graph of F should always be concave down. That didn't help. Try something else. F prime positive. So from x equals 0 to x equals 3, f prime is positive. So over that same span, f should increase. That's also unhelpful. You even need to repeat those, just worry about it. Cool. From x equal 3 to x equal 6, f prime is decreasing. Oh, negative, sorry. Therefore, f should decrease, but that didn't help either. So as I like to say, welcome to the AP test. Now, it's what they do to you. Like, they either, from the very beginning, get you to say, I don't know what to do, or partway through, you're suddenly like, I'm lost. It's not working how I thought it should work. Okay, what you need to practice all year is you need to practice when this happens. Like, you don't panic, you just pause for a minute and think, okay, what other information do I know that connects f prime to f? We've tried all of this, but there's another piece of information you haven't really used that connects f to f prime. Mary?
Just again, like where it starts.
Talk to me some more.
Like where, like see how it starts at 3 on the y?
So Mary's looking here, and that's x equals 0, and the y value is 3. Keep going, Mary.
And then maybe like where end at 6, -3.
So we're here, we're at, so 2 points for Marin. Somebody build on what she's doing, like Charles.
So whatever the y value is on the f prime one is going to equal the slope of f at that same point.
So Charles is looking here and saying, okay, x equals 0, y value of f prime is 3. So therefore at x equals 0 on f, my slope, my tangent slope, that's decent. It's a little bit flat. Bad. Good. I feel like that character in Harry Potter. Dobby, is that his name? Bad Dobby. That's a good one. Good job. Okay. So look, slope is rise over run. Come over 1. I do that one really good. That is like dead on. Pause for a celebration there. Small victories in life. Got a whole box full of participation stuff at home. Small victory. Just kidding. This slope is 1/2. It's over 1 up 1/2. So this one's right. Wait if you need to talk through it. So just nod if it makes sense. Are you clear that because this point on, remember, graphs are just points. So this point on f prime is 0, 3. But what that tells you about f is when x is 0, the tangent slope has to be 3. So I came here and I did my best to draw what the tangent slope would look like. Slope is rise over run. So I just did my best to estimate, and notice that on this one, if I go over 1 and up 3, that appears to be this slope. So that's a match. Whereas here, if I go over 1, I'm only going up 1/2. So this slope is 1/2. And that would mean that y coordinate would have to have been here. Is that better?
So could we do that with the other point, the 6, -3?
So here, at x equals 6, we should find the tangent slope to equal -3. So I'm not as good at drawing lines the other direction, so we'll try. Yeah. kind of shameful. But it's close enough for me to know that even though I've drawn it incorrectly, it's way closer than this one's going to be. Because this is still just kind of that up a half thing. So yeah, it has to work at every point.
So hold on. So like, why? So I don't even know how to put the question, but like, since I know it's like the 3, but it's like, why wasn't it the half? Because like.
So I'll get you to answer, then it'll stick better. So this is the x-coordinate 0, and that's just telling you where.
Yeah.
So there's a y-coordinate here of 3. That's on f prime. So you tell me, Justin, what does the 3 on f prime signify on f?
Maybe this slope's gonna be 3.
Slope's going to be 3 at x equals 0. Right here, when I draw a tangent and I count the slope, I go over 1, that's my run. So if I were labeling this, I'd say the slope is going to be, let's see, the bottom is 1, that's the run. The rise was only half. 1/2 divided by 1 is 1/2. So this line has a slope of 1. Question? Anybody else? Please.
The slope of f prime doesn't have a connection to the position graph, right? To the f graph, right?
So the slope of f prime gets plotted on f double prime as a y-coordinate, but it doesn't go backwards now. So whatever the slope is here, this slope is, the slope of f prime is the y values of f double prime. So f double prime is going to look like this. This slope is what? What's the slope? What's the slope? Try again. Say it louder. What's the slope? Say it louder.
-1.
Say it with confidence.
-1.
There we go. Okay, the slope is -1. So every y-coordinate of f double prime will have a value of -1.
So it's just
So this is the graph of f double prime. Just a bunch of points. Again, don't think of them as lines and curves. Think of them as points. Every one of these y-coordinates is -1. Because every one of these slopes is -1.
I'm confused how it kind of matches, like is it 0 and 3, how it transfers to 1 and 3, how the run is 1.
The run of this?
No, the run of
This
the
one?
One downward.
This one?
Yeah, that's
So when you're
0 and
trying,
3, how it's.
you're okay. When you're finding slope,
Uh-huh.
you're looking for the steepness of the curve,
Yeah.
the rate of change of the curve. So you're just saying, okay, from here to here on this line, I go over 1. But at that same time that I went over 1, to hit the line, I have to go up 3. This is how you counted slope years ago. Cool, next one. Please go to number 12. Okay. Okay, look. One thing, I'll say this all year long. This is not like a, how do I say this? I'm pretty certain that on the the ACT, that if you're doing the reading section of the test, that you can kind of skim the reading as fast as you can and answer questions. A lot of people look at the question and go back to the reading, that sort of thing. Is that fair? Okay. You've got to train yourself differently for the AP Calculus test. Going fast is not an advantage. Like, go slow and look very carefully at each detail. There's not a whole lot written here, but just you got to find the details. For example, super crucial to notice you're looking at F. Okay? So even though up here it says second derivative, don't skim it. Don't go, oh, second derivative, this is F double prime. this is f. It says right there, f. The question says the second derivative of this at points A, B, and C. So these are just different x coordinates. So they're saying, okay, you've got x coordinates at A, B, and C. At those x coordinates, on the graph of f double prime, would the y value be positive, negative, or 0? So that's what the question is asking. Look at the graph of f. You do not see the graph of f double prime, but can you, from the characteristics of f, figure out at these three x coordinates on f double prime, would the y value be positive, negative, or 0? That's the question. We need to talk more about what they're asking. Just wave at me. Quote. So, Danica's chart says, if I'm looking at f and I want to know the positive, negative, or 0-ness of f double prime, I should be looking here. Because the concavity of f tells me about the positive, negative, or 0-ness of f double prime. So at point A, the graph of f, you said aloud, what kind of concavity? Say it. Louder?
Down.
So if f is concave down, then the y coordinate at that same x on f double prime would have a negative value. You need me to do it again, just wait. Cool. Part B, okay, B is the spot where the concavity is changing from down to up. So that's an inflection point. So over here, if my f graph isn't concave up, and my f graph isn't concave down, which is what's happening at B, then my f double prime graph can't be positive or negative. There's only two other possibilities: 0 or undefined. Undefined is a bit of an exception. We'll just worry about that later. So at point B, f double prime is 0.
So basically, if the position graph is straight, we're just over 0. Basically, the f double prime label would be 0.
Well done, Justin. So what Justin said was, okay, if we had an f graph, and again, don't memorize that f and position are the same. They're not necessarily. But as an example, so f is our graph, and you said if f was straight, right?
Straight, so like a B, it was straight across.
Let's do a slight variation of that. Well, we can go straight across. If f is flat like this everywhere, then this tangent slope everywhere is 0. So every point on f prime would just be at 0. And then the slope of that's still 0. So f double prime would just look like this. That didn't work. That still didn't work. Change color. There we go. Like that. Is that what you meant? Question? And then part C, because f is concave up, f prime has to be positive. Negative 0 positive. Question? Cool, next thing. $15.
How do you want us to, how do you want us to show it?
Oh, good question, Jamie. This entire packet contains problems that have always been on the multiple choice section, because there really isn't a clear way to show how you're thinking necessarily. So for this type of problem, You just write whatever you need to write. If you can do it all in your head, it's fine. There's no requirement to write anything. So. Good question. Okay, 15. They give you a graph of f again. But now they want the signs of the function, that means f, the first and second derivatives in order. So now they want you to look at one spot, x equals 0, and at that one spot they want you to fill out this table. So 0, f. So remember, the values of f are simply the y-coordinates of f. So just say it out loud, please. Right here is the y-coordinate of f, positive, negative, or 0. Say it. Positive. Okay, the y-coordinates of f prime are the tangent slopes of f. So, right here, there's a tangent slope. Is that tangent slope positive or negative? Say it. Negative. So the y-coordinate on f prime would have a negative value. I'm going to talk through it again, just wait. So, every y-coordinate on f prime is an exact match with the tangent slope on f. So I'm looking at f. Here at x equals 0. I see a tangent, and I can't calculate that. Well, I guess I could, but I don't really need to. This slope is going downward. This tangent's going downward. That means the slope of this line will be some negative number. In fact, if we wanted to count it, it appears to be about, yeah, it's not quite -1. Negative's all I need. I don't care about the number. So if the tangent slope of f is negative, the y value of f prime must also be negative. There we go. What's that?
Can you repeat what you just said?
So if the tangent slope of f has a negative value, the y-coordinate of f prime must also have a negative value. F double prime. Look over here. When f prime is, see right here, f is concave up. So because f is concave up at x equals 0, f double prime must be positive. Positive, negative, positive.
Alright, so why do you, so you have x to 0 with?
So we're looking, so the point of x is to identify where should I be looking. And it says right here we should be looking at an x-coordinate of 0. So I am. I notice that at that spot on the graph of f, y-coordinate is positive. Tangent slope is negative, so the y-coordinate of f prime would be negative.
I get that.
Oh,
I'm
you're
trying to
good.
figure out how you got the f.
Oh, no worries. You're good now. Just anybody else? Just wave at me if you want me to talk through it again. Waving. No one's waving. Mary's just brushing her hair. No, you continue. It's fine. Okay, next one. I'm gonna make you guys all nervous. You'll be like all stiff all period. Go to 23, please. Okay, 23, another really good example. You must read slow and careful. But, you know, problems vary. Sometimes you can read slow and careful and figure out what's going on. Other times you kind of have to read it all once, then go back and read it again. This one's more the second category. So I start reading, but very carefully. F is a function that is continuous. That is a clue that is sometimes extremely valuable. Other times that clue is just kind of generic. Closed interval, -2 to 3, that's pretty generic. They're just telling you we're only going to look from here to here. That's it. So I'm good. That's common. Such that, this one's crucial, f prime of 0 does not exist. Okay, I have to decode that. I have to translate that to English. So, looking for help. What does the symbol f prime of 0 mean? What does that mean in English? Please.
Like, what is the y value when x equals 0?
On which graph?
On the f graph.
Perfect. So everyone, memorize exactly what Carson just said. Like, make sure you've got it memorized. Make sure whenever you see something like this, you can recall it instantly. Like, you've got to be that fluent with the notation to just see this and go, oh, if I were looking at f prime, I would see this is the y coordinate when x is 0. So it says on the graph of f prime, the y coordinate when x equals 0 isn't there. So if you were looking at a graph of f prime, and you got to x equals 0, there would not be a point shown. I don't know where that marker would be, but there would be nothing there. So that's one meaning of this. Just wave if you need me to repeat that. You have to know that, and it's crucial, and it's all your own. Do you need me to repeat it?
So basically it's saying that f prime at x equals 0 does not have a y coordinate.
Correct. F prime at x equals 0 does not have a y coordinate. Perfect. Okay, there's a second meaning to this that relates to the graph of f. You can tell me what this means in terms of the graph of f. Please, Abby. Can't find the slope. Because the y coordinates of f prime are the tangent slopes of f. So I read this and I think of two things that you have to do it quickly and easily. You're thinking, okay, on f prime, there's no point at x equals 0. On f at x equals 0, I can't find a tangent slope. You need me to repeat that.
Basically what that's saying is on the f graph, you can't find the slope at 0.
Perfect. On the f graph, you can't find a slope at x equals 0. Okay, another thing to put on your list of things to memorize. There are 3 ways that a graph will not have a slope. The first way is if there's a discontinuity. So if a graph has a discontinuity, it will not have a tangent slope at the discontinuity. You need to memorize that. So number 1, if a graph has a discontinuity, no tangent slope at the discontinuity.
So would that be like D on the 23?
So D, what kind of discontinuity does D have? Jump. So D does not have a tangent slope at x equals 0. D does not have a tangent slope at x equals 0. So that's one way, is to have a discontinuity. Okay? And you've already memorized that there are 3 types of discontinuities. Jump, removable, vertical asymptote. Okay? Second reason why you can't have a tangent slope on a graph is if the graph has what's known as a corner. So a corner is a spot on the graph where, so again, we're looking at f. It says f prime of 0 does not exist. That means that f has a spot at x equals 0 where you can't find the slope. Another way of doing that is with a corner. A corner is where the slope changes suddenly. So along here, the slope's all the same, the slope's all the same, but right at the corner, the slope is dramatically different. Another example would be if you have a curve, along the curve, the slope is changing very gradually, just like in infinitesimal steps. At the corner, the slope suddenly changes instantly. Questions about a corner? There's somebody at the door. I'm not sure why they're standing at the door.
Sorry, it's a
Oh, it's just you. Oh yeah, please, please, please.
So would that like represent like A or B of the question?
Very good. So right here, x equals 0, corner, that means on this graph, there is no tangent slope at that spot. No tangent slope here. This one has a tangent slope. This one does not have a tangent slope.
So does that mean we can cross out C and C is
So
not?
C cannot be the correct answer because they're asking which of the following is a graph of f, and we're supposed to find an f where there isn't a slope at 0. This f has a slope at 0. B does not have a slope at 0. That's good. We don't want a slope at 0.
D.
Oh, D. D also does not have a slope at 0 due to the corner. So that's good. We don't want to have a slope at. Did I keep saying you wrong?
Like D, like dog.
Oh, D. Old age. Too many power tools is my problem. Seriously. The jump here also no slope at D. We don't want to have a slope at D. So you wouldn't cross it off for that reason. Okay, so this is the one that has a slope at D. It's also just one comment. It's also a good example of again what they do on the AP test. They get you going in circles. Because you're like, wait a minute, I'm supposed to find the graph that matches this, which means I want a graph that does not have a slope.
What would this look, if this was a position graph, like what would it look like if you were, like if you were moving like this?
Traveling?
Yeah.
Which one are you talking about?
Just
Any of them?
The corners.
Well, at the corner, so the corner indicates that the slope of this graph is the position of the slope of the graph is the velocity of the particle. So it means the velocity changes like instantly somehow. So not necessarily a type of thing I can reproduce in the real world. I don't know how to make a particle be going one velocity and then instantly change to a different velocity. But that's what the graph is depicting.
It's not like
It is it's saying like a different time, like the slope of this graph is the velocity of the particle. So the velocity is negative, less negative, less negative, less negative. Suddenly the velocity is positive. So it's moving leftward, it's slowing down, and then suddenly it's moving to the right, like at a much higher rate than
So
it
what
was.
it's saying is it doesn't stop.
It doesn't stop.
So it's like going in bangs.
Suddenly it reverses its direction. There's no place where it stops. I don't know how you do that.
Is there another one?
Oh, please,
Can we
save me.
cross out B because it's like.
Listen to Sydney. We're looking for a graph of f. No, it's a good comment. Listen to Sydney. We're looking at the graph of f. F is supposed to be continuous. D is not continuous. Listen to Sydney. It should be like a bumper sticker.
Oh, I like that. They're both like really You would.
Okay, questions? You may need to repeat anything. Okay, keep going. Look. Oh, one more thing for your memory list. The third way to have a function that does not have a tangent slope is that the function has a vertical tangent. So discontinuity is one way, corner is the second way, third way is vertical tangent. Vertical tangent looks like this. Graph's going along just fine, and then does this weird thing where at one point it goes straight up. So vertical slope is undefined, hence I don't know what that slope is.
Okay, can it be off of a corner as well, or just like?
You could have, yeah, you could have a corner. Like you could have a graph that went, you know, then it wouldn't be a function technically. But, so I've never seen them ask that, but it's good. Anybody else? Okay, keep reading. It says f prime of 2 should be 0. Whole class, please. I'll pay everyone who raises their hand. What does the symbol f prime of 2 equaling 0 mean? It has two meanings. You must remember both meanings. Come on. Hands. Talk to each other. Get your hands up. Hands up. Come on, show me hands. What are the two meanings of that symbol? Hands. Come on. Everyone who raises their hand. What's the double meaning of that symbol? About half of you, School of Lawrence.
So f prime of 2, the y-coordinate is 0, and then on the f graph at 2, the slope is 0.
Well said. So on the f prime graph at x equal 2, the y-coordinate would be 0 on f prime. On the f graph at x equal 2, the slope must be flat, or 0 at x equal 2. Okay, how many had their hand raised? Point. How many knew it before she said it? Point again. So we're running out of time right here. X equal 2. Slope is 0. X equal 2. Slope is 0. No, it isn't those. X equal 2. Slope is 0. Dirty rats. Okay. Not helpful.
So did they just like throw stuff in?
Oh yeah. Their goal, it's simple. Their goal is simple. Find a way to determine if the student understands calculus or simply tried to memorize it. So they do all kinds of things like this to get you away from, oh wait a minute, I've done this problem before. That's why every year, no matter how many practice tests we take, students will come back and say, this year was the hardest. This year was the most different. It's because it always is. It's not harder, it really isn't. It's just different. And so what you're trying to get used to is what you're going to experience in the workforce, where things are different than school. School is like your base, but it was amazing. Like I spent 5 years studying engineering at BYU. I get like my first job, I didn't know anything. So anyway, homework is the practice with the work.
Oh yeah.
You're good. So we go to the next one. It says f double prime is less than 0. So this symbol means this symbol's kind of tricky later. Because in some reading, this will mean x and y. But in this instance, it means y value. So it's saying all the y values of f double prime are negative. So I look over here. F double prime is always negative. The y values are always negative. So f must always be truncated down. No, this says f double prime is negative. Okay, f double prime is always negative. That means f is always going to be down. So which of these is always going to be
So basically what you're saying is like you wouldn't just straighten that
if you're lucky, there's no way you don't get to honest, but you're right.
question you could.
Oh yeah. So when I guess all these things are working.